Welcome to the Explainer. Today, we are unpacking a massive architectural shift that's happening right now in enterprise data. For years, organizations have heavily relied on these rigid, manually coded data pipelines. But today, we're stepping into a thrilling new era of highly adaptive, AI-driven architectures. To kick things off, let's just ask a really fundamental question. What happens when your data architecture simply cannot keep up with your data? Well, it usually means a whole lot of late nights and cold coffee for your data engineers. We live in a reality where data volume and complexity are absolutely exploding, yet so many businesses are finding themselves completely bogged down just because their traditional pipelines are stubbornly stuck in the past. So here is our roadmap for today. First, we'll look at the data bottleneck problem. Second, how AI automates data pipelines. Third, self-tuning data warehouses. Fourth, the AI security blind spot. And finally, securing AI with DSPM. Let's dive in to Section 1, the data bottleneck problem. Think about traditional ETL for a second. It relies on fixed schemas and scheduled batch processing, which basically means it breaks incredibly easily. If a regional database changes a column name from, say, cust_ID to customer_identifier, that pipeline snaps, and that costs you days of manual recoding from an engineer. But AI ETL, it uses dynamic transformation. When that exact same schema change happens, the system just figures it out contextually and maps the new field automatically. And that brings us to a pretty staggering reality. 80 to 90% of enterprise data is completely unstructured. We're talking about your PDFs, clinical notes, images, transcripts. Traditional batch systems are practically blind to all of this. I mean, they excel at structured rows and columns, but they fail miserably when trying to extract insights from free text. This creates a massive bottleneck where your organization's most critical insights are quite literally just sitting there in the dark. Moving on to part 2, AI automates data pipelines. So what exactly is AI ETL? It's essentially combining artificial intelligence with your extract, transform, and load processes to dynamically learn patterns and adapt to schema changes on the fly. Instead of a human writing explicit rules for every single data variation, these platforms use machine learning, natural language processing, and computer vision to actually understand the semantic meaning. They can look at a scanned invoice, identify the vendor and the amount regardless of how it's laid out, and seamlessly integrate that unstructured data right alongside your traditional databases. Now, a super common concern here is what this means for the human workforce, right? Are we replacing engineers? Enter the 30% rule. This guideline dictates that AI automates about 30% of routine tasks, things like standard schema mapping and those routine quality checks. The remaining 70% is handled by humans. AI isn't here to replace data engineers, it's just here to take away the boring parts. By offloading that tedious 30%, your engineers are finally free to tackle the really complex edge cases, governance frameworks, and overall strategic architecture. Let's shift gears to Section 3, self-tuning data warehouses. To understand how this leap actually works, consider this ML-driven data warehouse optimization framework from EA journals. Your data sources and workloads are constantly generating telemetry, things like query logs and system metrics. This telemetry flows continuously into feature engineering, which then feeds an optimization layer. This allows a warehouse to autonomously tune its own indexes, adjust query plans, and scale resources, all wrapped up in a continuous governance and feedback loop. It's essentially a self-driving database. How cool is that? And behind the scenes, you have different machine learning approaches working overtime. Supervised learning handles the predictions, estimating query costs and runtimes based on historical data. Reinforcement learning treats query planning like a game, using trial and error to learn the absolute optimal joint ordering. Meanwhile, unsupervised learning acts as your silent guardian, constantly running anomaly detection to ensure proactive data quality checks happen way before bad data can ever corrupt your analytics. The performance gains from all this ML tuning are honestly incredible. Compared to traditional rule-based optimizers, this framework delivers a 30 to 45% reduction in query latency. It also requires 25% less storage overhead because of learned index structures, and it operates with 20% lower CPU and memory usage. Just imagine what those efficiency gains do to your monthly cloud bill. It is faster, it's cheaper, and it's vastly more efficient. Which brings us to Section 4, the AI security blind spot. So, solving these massive data bottlenecks with AI is great, but it creates a new, arguably more dangerous vulnerability: shadow AI. These are unauthorized AI tools or developer-provisioned models operating completely outside of IT visibility and governance. You've got employees plugging sensitive enterprise data into personal Copilot accounts or unapproved web tools. These over-permissioned agents create dangerous, persistent blind spots that traditional network monitoring and static cloud scans simply were not built to catch. And this leads us directly to a massive, and I mean highly expensive problem: irreversibility. If sensitive, personally identifiable information, or PII, accidentally gets trained into an AI model's weights, it cannot be selectively deleted. You can't just go in and drop a row in a database anymore. If regulated data is ingested during fine-tuning, you are forced into a complete, incredibly costly retrain of the entire model. Finally, Section 5, Securing AI with DSPM. So what's the fix here? It's DSPM for AI. That stands for Data Security Posture Management, and it continuously discovers, classifies, and governs sensitive data before it ever flows into your AI systems. And that word before, it is absolutely everything. While traditional tools scan static cloud buckets after the data is already stored, DSPM for AI intervenes upstream, in real time, preventing sensitive data from reaching those model weights and triggering that massive irreversibility headache we just talked about. Implementing this requires 4 critical phases. It kicks off with AI-aware discovery, finding every vector database, prompt log, and shadow AI tool out there in your environment. Next is AI readiness classification, which clearly separates safe public data from restricted PII. Then, data lineage tracking maps that data through every single transformation it takes. Finally, pre-ingestion enforcement steps in, automatically blocking risky training jobs or redacting prompts right on the fly. You're shifting security from reactive scanning to proactive guardrails. When you get this implemented properly, it neutralizes some highly complex threats. It wipes out access debt, where AI agents somehow inherit overly broad permissions. It stops RAG corpus poisoning dead in its tracks, and crucially, it catches untracked AI-generated derivatives. Like, for example, when an AI summarizes a highly confidential document and naturally inherits its sensitivity. This is how you finally secure that massive 80 to 90% of unstructured data. I want to leave you with this really provocative thought from Cyberhaven. Are you just feeding your AI, or are you actually governing what it eats? Take a second to really question your own organization's approach here. Are you blindly adopting these incredible autonomous AI tools without securing the upstream data first? The architecture of the future is definitely intelligent, but it absolutely must be secure. Thanks so much for joining me on this explainer, and keep learning.